Hey guys, welcome back to the laboratory. In this video, we are looking at covalent bonding. By the end of this video, you should be able to define the term covalent bond, describe how elements react to form molecular substances, and draw dot and cross diagrams to show how elements interact to form molecular substances. So, let's go. Molecular substances contain groups of atoms that are held together by covalent bonds. A covalent bond is a shared pair of electrons, and these bonds are formed when two or more nonmetals share their electrons to achieve a full outer shell. With a full outer shell, the atoms become stable. Let's look at the bonding in a molecule of fluorine as an example. Both fluorine atoms need one extra electron to have a full outer shell of 8 electrons. To achieve this, the atoms share one pair of electrons, forming one covalent bond. If we cover the outer shell of each atom, we can see that this fluorine atom now has 8 electrons, and if we do the same over here, we can see that this fluorine atom now has 8 electrons too. We can use the valency of an element to determine how different substances will bond when they react with one another. The valency of an element tells us how many chemical bonds it can form. This table shows the relationship between the outermost shell of an element and its valency. The valency of the element is always equal to the number of electrons needed to fill the element's outer shell. So for example, nitrogen has 5 electrons on its outer shell. To achieve a full outer shell, nitrogen needs 3 electrons and can therefore form a maximum of 3 bonds at a time. Let's look at the bonding in carbon dioxide to explore this concept further. Both oxygen atoms need 2 electrons to fill their outer shells and can therefore form a maximum of 2 bonds. Carbon needs 4 electrons to fill its outer shell and can therefore form a maximum of 4 bonds. When the atoms react, we can now see that this oxygen atom has formed 2 bonds with carbon, and this one has formed 2 bonds with carbon too. And the carbon atom has formed 4 bonds with both oxygen atoms. When you're drawing a dot and cross diagram for a molecular substance, it's important that each covalent bond contains an electron from each element. This dot and cross diagram for carbon dioxide is inaccurate, as the electrons in each pair are from the same element. Do make note of this for future reference, as you will likely be penalised in your exam for making this mistake. There are several models that can be used to represent the bonding between atoms and molecular substances. Each of these models are preferred for different reasons, as they each have their own advantages and disadvantages. The first of these models is the molecular formula. This model uses element symbols and subscript numbers to represent the bonding in a substance. An advantage of this model is that it's easy to understand. A disadvantage is that it does not give any detail as to how the atoms interact and form bonds with each other. Next up is the structural formula. This model consists of element symbols connected by these short lines that represent chemical bonds. An advantage of this model is that it shows the number of each element present in the molecule. A disadvantage is that it does not show the relative sizes of each atom. Next, we have the ball and stick model. This model consists of spheres and rods, where the spheres represent the atoms and the rods represent the chemical bonds between them. An advantage of this model is that it shows the relative sizes of the atoms. A disadvantage is that it does not show how the electrons have interacted to form bonds. And finally, we have the dot and cross diagram, which gives a visual representation of the sharing or transfer of electrons between atoms. An advantage of this model is that it shows what happens to electrons when bonds are formed. A disadvantage is that the model suggests atoms have different electrons, when they are in fact all the same. Here's an example of how you may be assessed on this particular concept. Pause the video, read the question, and take your time to answer. I'll be waiting for you on the other end with the mark scheme. This question has asked for you to draw the dot and cross diagram for a molecule of hydrogen chloride. Using the electronic configurations of hydrogen and chlorine, we can see that both elements need 1 electron to fill their outer shells. We know that the number of electrons needed to fill the outer shell is equal to the number of bonds an element will form. Therefore, both of these elements will form 1 covalent bond. This is supported by the structural formula provided in the question, which shows there is only 1 covalent bond formed between the hydrogen and chlorine atoms in the hydrogen chloride molecule. When drawing the dot and cross diagram for molecular substances, I always start with drawing a covalent bond, or bonds, and then work my way outwards. Hydrogen and chlorine have 1 covalent bond between them, so we draw this bond here. Now we can use the information from the question to finish the outer shells of each atom. Hydrogen only had one electron to begin with, and this electron is now being shared in the covalent bond, so we leave the outer shell for hydrogen as it is. Chlorine had 7 electrons on its outer shell, and one of these is now being shared in the covalent bond, meaning there are 6 electrons remaining on its outer shell. Your first mark is awarded for drawing the covalent bond, and your second is awarded for correctly drawing the outer shells for each atom. And voila! So, how did you do on this question? Let me know in the comment section below. Anyway, that's it for this video, guys. Thank you for joining me in the laboratory. Please leave a like on this video if you found it useful, and don't forget to subscribe to the channel so that you don't miss another one. See you soon!